Well, welcome back with that eerie music. See if you can name the title to that theme song. Our topic today is Pythagorean and Trig identities, and this is a big one. So again, stay with me. If I talk too fast, pause it, rewind it. We've got to get these down tonight. Okay, so it's in your hands. All right, we've got some trig identities to get down today. So let's start with some nice easy ones. If I wanted to write sine as a fraction, would you agree I can simply just say that's sine theta over 1? If I wanted to write cosine theta as a fraction, I can say that's cosine theta over 1. And obviously tangent theta, I can say that's tan theta over 1. All right, those should be extremely obvious. Now, let's talk about some more. If I want cosecant theta, all I'm saying is this guy is the reciprocal of sine. And what does reciprocal mean? Well, it simply just means to flip your fraction. So if I flip sine over 1, I get 1 over sine. Okay, so cosecant is 1 over sine. Let's get secant. Okay, so secant theta is going to be the reciprocal of cosine, and if cosine is cos over 1, this of course is 1 over cosine. And last but not least, we've got our cotangent theta, which if tangent's tan over 1, this of course is 1 over tan. All right, now those might seem pretty easy, and hopefully they are by now. I've got some more to throw at you today. Big idea number 1. Tangent can be represented another way. Tangent is equivalent to sine over cosine. And we've talked about that in a previous video, so I'm going to leave it like that at the moment. If tangent is sine over cosine, then if I want cotangent, basically all I'm going to do is take this fraction and flip it. I'm going to say cotangent is cosine over sine. Those are going to be two big properties that we use today. All right, so what's a typical question going to look like? Well, here we go. Number 1, simplify cotangent theta times secant theta in terms of sine theta. Now that might sound a little overwhelming, but it's in fact pretty easy. Keep the list of functions that we just wrote down in front of you. So here's how I attack it. I'm going to replace cotangent theta with something, and I'm going to replace secant theta with something. So I say to myself, okay, cotangent is the reciprocal of tangent. So I could say that's 1 over tan theta. Hopefully you would agree with that. Reciprocal of tangent. And secant is the reciprocal of cosine. So I can say, okay, that's 1 over cosine theta. All right, now, you'll notice that that wasn't very useful. Nothing cleans up. Nothing's very nice. Watch this trick. I'm going to say this wasn't helpful. Could I replace cotangent with something? Well, look back at your notes there. What is cotangent equivalent to? And hopefully we have written down cosine over sine. So I'm going to now replace cotangent with cosine theta over sine theta and see if that's more useful. There was nothing wrong with what I did first, it just wasn't useful. It didn't help me at all. Now take a look. I think this is much more nice. You'll see on top you have the cosine, and on the bottom you have a cosine, and anytime you have the same on the top and bottom and you're multiplying, they cancel each other out. So what's left? Well, just ask yourself, on top, if you take a look, all you have left is the number 1, and on the bottom all you have left is sine. So I would say this answer is 1 over sine theta, and we're done. Now, you'll notice they said leave it in terms of sine, that's why I'm stopping there, but who is this also equivalent to? Who is 1 over sine? Well, that's the reciprocal of cosecant. So that's another equivalent answer. All right, let's try another one. This is expressed in simplest form. Cosecant times tangent times cosine is equivalent to what? So again, I'm just going to replace all 3 of those terms with what they stand for. Okay, so start with cosecant. Cosecant is the reciprocal of sine, so that would be 1 over sine theta. Tangent. Now, you could leave it as tangent over 1, and we'll see if that helps us, may or may not. And that last one was cosine, so I'm just going to basically leave that as cosine over 1. All right, so I'm going to ask myself, is that useful at all? Well, does anything cancel? I don't see anything that cancels. So I'm going to say, okay, tangent special. You can write tangent as something else. So So I'm going to say tangent, remember, and look back at your notes. What's another way to say tangent? Hopefully you've said it by now. I would say tangent is sine over cosine. And now look what happens. I have a sine on the bottom and a sine on top, a cosine on the bottom and a cosine on top. Now my answer is not nothing. I basically have 1 times 1 times 1. These cancel to a 1, of course, and these cancel to a 1. So I've got 1 over 1, which is really just 1. Let's try another. The expression cosine y times cosecant y minus secant y is equivalent to what? All right, so just use common sense first. What do you think you should probably do with this cosine y that's in front of something in parentheses? Think of it as 3 times x plus y. What does common sense tell you to do with that 3? Well, if it's in front, I would distribute it. So I'm going to say I get cosine of y times cosecant of y. Okay, so I've distributed that, minus cosine of y times secant of y. So again, I think common sense just tells you to distribute. Now I'm going to rewrite each of these, and notice there's a minus sign in the middle. Okay, so cosine y, nothing really fancy to do besides put it over 1. Cosecant of y is the reciprocal of sine, so that's going to go to the bottom. Cosine y, again, nothing fancy to do but put it over 1. And secant y is 1 over cosine of y. All right, let's see what we have here. Can anything cancel in this first set? Well, sine and cosine don't cancel, and there's no other way to rewrite sine or cosine. So what am I left with? Well, on top, when you multiply, you get cosine of y. And on the bottom, when you multiply, you get sine of y. Can't really do anything more. On this side, my cosine y's are going to cancel, and technically my 1's cancel, but remember they all multiply or divide out to the number 1. It doesn't disappear into thin air. Cosine divided by cosine is 1. 1 times 1 is 1, divided by 1 is still 1. All right, now, I can simplify this further. Who are you staring at? Who is cosine over sine? Look back at those notes we made. Hopefully you're saying this is cotangent of y minus 1. And that's as far as I can go, and I would say that's my cleaned up answer. Next example. We've got secant divided by cosecant. So again, I'm going to rewrite the top and rewrite the bottom this time. So secant is the reciprocal of cosine, so I'm going to say that's 1 over cosine. And cosecant's the reciprocal of sine, so hopefully you know that's 1 over sine. Now look how exciting this is. Look what they've thrown at us. They've turned this simple little thing into a complex fraction. So now we've got to treat it like a complex fraction. What is your common denominator? Well, this guy has a denominator of cosine, this guy of sine. So I'm going to multiply both the top and bottom by cosine theta, sine theta. Cosine theta, sine theta. All right, so let's just start with that top piece. What multiplies out? Well, I've got a cosine on top, cosine on the bottom, so I'm left with 1 times sine, which is just sine, all over. Sine on the bottom and top, those cancel, and I'm left with just 1 times cosine, which is cosine. Now that's not going to be a multiple choice answer because look back at those notes. What is sine divided by cosine? That, my friends, is tangent. And that would be the answer they're expecting to see. All right, let's try another one. Cotangent divided by cosecant. So again, I'm going to rewrite each of these. Now cotangent, you could be thinking 1 over tangent. And cosecant, you could be thinking 1 over sine. But I don't know. This tangent is never very useful. We could leave it like that, but we could also replace cotangent with who? Remember, tangent is sine over cosine. So cotangent is going to be cosine over sine, and the dog is going crazy. So I think, in fact, it would be better to use cosine over sine divided by 1 over sine. Now, this is really nice because look at your denominators. What is your common denominator this time? It's definitely sine. So when I multiply the top by sine and the bottom by sine, those cancel, and here I get cosine on top. Those cancel, and I'm left with 1. So my final answer is just cosine. Now, another little tip is that if you ever do have the same bottoms completely, you can just cross them off to begin with, and you're left with just cosine. All right, so here it is. here we're going to discover our godfather, our Pythagorean identities. And this is the main trig identity that we're going to use here. And notice I'm calling it a Pythagorean identity. It's very similar to the Pythagorean theorem. So go ahead and get your unit circle drawn out. And let's just make a note that this is the unit circle. Okay, I've got my axes in there. And I'm going to draw just my triangle in the first quadrant. Remember, it looks like a piece of the bow tie, sits on the x-axis, and here's my theta. All right, so I'm throwing a little review at you. We said this distance is the x distance, and this distance is the y distance. And because it's a unit circle, that means it has a radius of 1. So go with me on this. The x distance in trig, we said every point x, y in trigonometry. So think back, we said we can use some trig terms, and we're going to call it cosine theta, sine theta. So I can replace this x here with cosine theta, and I can replace this y here with sine theta. So go with me on this, the Pythagorean identity. So you'll recall the Pythagorean theorem is a squared plus b squared equals c squared. And the whole key is that your c must be the hypotenuse. So now let's apply that in this problem. My a is my x squared plus my y value squared. And in this case, my hypotenuse is always going to be 1 because it's the unit circle, and 1 squared, of course, is just 1. But now let's put it in terms of trig. We said in trig, we can call this x distance cosine. Now notice where I'm putting my squared. It's actually read cosine squared theta plus the y distance, which is sine squared theta, equals 1. And that's it. Box that first identity in. This is our first Pythagorean theorem, also known as the godfather. And this is where all of our other theorems are going to come from. So let's make a note here that this is the Pythagorean identity number 1. Now, there's 2 more that go along with this. And I'm going to show you how we derive them, or how we get them. Basically, I'm going to take my godfather, my first Pythagorean identity, I'm going to rewrite it out, and you should be doing the same. Cosine squared theta plus sine squared theta equals 1. And let me make one note. Does it matter if I say sine squared plus cosine squared? Obviously not. If I say 2 plus 3, is that still equal to 5? Or 3 plus 2, that still equals 5. So it doesn't matter which way you put these. But sine squared plus cosine squared equals 1. So to get my other one, okay, so let's make a note. To get the others, all I'm going to do is I'm going to divide all terms by, and this time I'm going to divide everybody I see by cosine squared theta. Okay, basically I'm saying just divide by this first term here. So watch as we do that, and again, you should be writing the same thing out. Cosine squared theta plus sine squared theta equals 1. And I'm going to put divided by each term I see, cosine squared theta. Alright, and now I'm just going to ask myself, what am I staring at? Well, what's any term here divided by itself? That's easy. That's just 1. Okay, sine squared over cosine. Remember, we said that sine over cosine is tangent. So because those are both squared, I'm going to call this tangent squared theta. And 1 over cosine, okay, if cosine's on the bottom, 1 over cosine, who's that's reciprocal? Well, I would say that is secant squared theta. And again, I'm keeping it squared because this is cosine squared. And box that in. That is our Pythagorean identity number 2. Okay, so we're going to ask you to get these on your own, not just memorize them. The only one you have to memorize is this first godfather, cosine squared plus sine squared equals 1, and then you can easily get the other ones. Watch how we get the third. Let's take that godfather again. Oops, our cosine squared theta plus sine squared theta equals 1. So that's the one you're memorizing. Now, last time I divided everybody by cosine squared. Instead, this time let's divide everybody by sine squared. So there's 3 terms. Everybody gets divided by it. Sine squared, sine squared, sine squared. And let's see what we get. Cosine over sine. Well, remember sine over cosine was tangent, therefore cosine over sine is cotangent. And because they're squared, it's going to be cotangent squared. Anybody divided by itself is 1. And 1 over sine is the reciprocal of cosecant. And because it's squared, I'm going to say it's cosecant squared. And box that guy in. That is trig, Pythagorean identity number 3. And there are only 3 of them. So take your time there. I just divided everybody by sine squared and everybody by cosine squared to get those. So please don't memorize them. Okay, now that we have our godfather and our Pythagorean identities out, I just want to run through it again. This is such a huge deal. The one you're memorizing is sine squared plus cosine squared theta equals 1. That you have to commit to memory. The other ones are very simple to get. You just divide everybody you see by sine squared or by cosine squared. So watch as I run through. Sine squared divided by cosine, sine squared is 1. Cosine over sine is cotangent, and because those are squared, it's cotangent squared. 1 over sine is cosecant squared. Or I could have divided everybody by cosine squared. Sine over cosine is tangent, and they're squared. Cos over cos is 1. 1 over cos is secant. And those you'll have to be able to get on your own. They're not given to you on the exam. So I want to be clear, you have to get those on your own. Now, let's look at some problems that involve that. This time, I need to simplify this expression. And what do you notice on top? Sine squared plus cosine squared. What can you put there? Look at these identities. What is sine squared plus cosine squared equal to? Hopefully you're saying that's the Godfather rule. That's our first Pythagorean identity. And sine squared plus cosine squared equals 1. So I'm going to replace all of that with 1 over cosine x. Now this is simple. Who is 1 over cosine x? Well, that goes with secant x. And there's our final answer. Let's try another. Okay, I've got sine squared plus cosine squared over 1 minus sine squared. What is this equivalent to? Well, do you see it again? You're staring at the Godfather. You're staring at that first Pythagorean identity. Sine squared plus cosine squared is equal to 1. So I can replace the top 1 over 1 minus sine squared theta. Now let's talk about canceling. Remember, you don't cancel unless you cancel with everybody. It has to be even. You cannot just kill those ones. It's got to be fair. Now here's where they get sneaky. Stay with me. This kind of looks like the Godfather, our Pythagorean identity here. Kind of looks like it. Not quite, but kind of. Watch what I do. I can, manipulate this equation up here. I can move this around any way I want. I'm going to say cosine squared theta is equal to 1 minus sine squared theta. And that's legal. Think about what I did. I basically just said subtract sine squared theta from this side and subtract sine squared theta from this side. Well, if I do that, that disappears and I'm left with cosine squared. Then I have an equal sign and I'm left with 1 minus sine squared. So watch what I can substitute in now. 1 minus sine squared is actually equivalent to cosine squared. Now, if 1 over cosine is secant, who do you think 1 over cosine squared is? Well, I would definitely call this secant squared. Now, don't get me wrong, my answer wasn't incorrect here, it just wouldn't be the multiple choice answer. You would have to keep playing with it until you got their answer. And the whole trick was saying, this looks like the Pythagorean identity, how can I change it so it helps me? Next one, sine of A plus cosine squared A over sine A. Well, in this case, to me, I see 2 fractions trying to be added together, or 1 fraction and something that's not a fraction, but I'm going to make it a fraction by putting it over 1, just like you've probably guessed by now. So let's review adding fractions. You need to look for a common denominator. Well, you have a 1 and a sine A. I would definitely say my common denominator is sine A. So again, when I add fractions, I'm getting a common denominator and making one big fraction. I'm going to multiply the first fraction by sine A, and the second fraction already has sine A. I only need to multiply it by technically 1, or I'm good to go. So I've got sine A times sine A is sine squared A. Notice where that squared is. plus cosine squared A. Do you see it happening again? Do you see what you're staring at on top? That's got to jump off the page at you. Sine squared plus cosine squared from the Pythagorean identity is the number 1 all over sine A. And now hopefully this jumps out at you. This is actually cosecant of A. All right, our next example, tan x minus cos over cos. Okay, now you might be saying, I don't see anything too crazy I can substitute in. Well, don't forget tangent's pretty special. Besides being just tangent over 1, remember tangent is sine over cosine. So I'm going to replace that right away. Now since I turned that into a fraction, I'm going to make everybody a fraction. Cosine is really just going to be cosine over 1. And again, cosine on the bottom is going to be cosine over 1. Again, look what I've turned it into. I've got this beautiful complex fraction. So, just like we did in class before with regular, numerical values, we're going to just find our common denominator. I see a cosine, a 1, and a 1, so I would say my common denominator is cosine x. And again, every term gets cosine x. Now, they only cancel if you have 1 on the top and 1 on the bottom. So clearly top, bottom, I'm left with just sine x. Then there's a minus sign. Do these cancel? Heck no. They're both on top. What is cosine times cosine? I would say that's cosine squared. Same thing on the bottom. Do these cancel? No again. Top, that's going to make cosine squared. Now, at this point, do you have the godfather? Don't get tricked by it. The godfather is sine squared plus cosine squared. And this isn't even a squared term. And that's not a plus sign, so you don't have it. But we could do something else, perhaps. We're going to call this make like a beaver and split. Okay, now this is special. You can only make like a beaver and split when there is one term on the bottom. Okay, it only works if there's one term on the bottom. And now what do I mean by make like a beaver and split? Well, when you're dividing, you're actually dividing everybody you see. Okay, I'm dividing sine by cosine squared, and I'm dividing cosine squared by cosine squared. So watch how I write this. I'm going to say it's really sine of x divided by cosine squared x minus cosine squared x over cosine squared x. Do you see what I did? I split, make like a beaver and split. I split those two because there was one term on the bottom. Now I think I can clean this up just a little further. What does anybody divided by itself turn into? Doesn't disappear. It turns into the number 1. So I've got sine over cosine squared minus 1. And I think that's as far as I can go. Well, we've done quite a few examples in here today, so hopefully you've got good notes. Remember, it's in your hands. Pause it, rewind it, come to class prepared tomorrow, and we look forward to seeing you. Have a great night.